Okay, so we are going to go ahead and get started, and Esther will take the first topic, which will be it's going to be classes and objects, and then Ruth will take the second, which will be file processing and the pickling module. Then regular expressions, Esther will help us. Somebody was supposed to cover that, but they are traveling, so we're going to go ahead and just do this. All right, so Esther, go ahead and get started, if you would, please. And thank you very much for taking this opportunity. Okay. I'll go ahead and shut up so you can go ahead. Thank you.
Okay. So let me just share my screen. Okay. So I'll talk about object-oriented programming. So that involves it's another paradigm. We talked about procedural programming, functional programming. Now we will talk about object-oriented programming. So when it comes to object-oriented programming, it involves creation of classes and objects. And if you remember from the first time we started with variables, when we were looking at the type of variable that we had when we created a variable, say name, age, and then we also last time created functions. And if we use the type function, we are able to see that they belong to a class, string or str class, int and class function. So basically, anytime you create a variable and a value, you're creating an object. You're creating an object from a particular class. So Esther, the name equals Esther would be an object of class string. Age equals 26 would be an object of class int. And if maybe you don't follow, because Paul, if you don't follow or as usual, if you don't get anything I'm saying, feel free to stop me. I'll just continue. So most of the time, programmers tend to use object-oriented programming, and Python gives us facility. And what the first thing you need to do is create a class. So what is a class? It's like a blueprint. It is what like shows the building blocks of the object. Like it's not a data structure in itself. So like string, int, function, those are inbuilt. They come anytime you install Python. They come with Python installation. Those are so that we call them inbuilt. But you as a programmer, you can create your own classes. And those classes are now what we call as a blueprint. So how do we create a class? We use the class keyword and then simple, just use the class keyword and give the name. So for instance, I have a class called my pet, and inside it, you can use these three quotes. This is a doc, it's known as a doc string. So the way you have a string, if you use single or double quotes, your string needs to be in one line. But maybe you want to write about this class, you might want to write many lines, multiple lines. So we use these three quotation marks and create something known as a doc string, which is a multi-line string. So in this case, I used the class keyword and I used the name my pet. And there is a convention when it comes to naming the classes. I remember we were taught of different ways you can have the snake case where you use the underscore. Then we have the camel case where you capitalize each word. And that is how we name our classes by capitalizing each word. So here N is capital, P is capital. That's how we name classes. That's the convention. That's the right way. It doesn't matter. It doesn't mean that if you use all small lowercase, it won't work, but the right way to name it is using this convention. So once you create a class, you can actually now create an object out of the class. You remember how we did with functions? You can create an object out of a class. So here we created an object called set underscore object obj, and now this is known as instance creating. We give an instance. You create one instance of the class. So now we have created an object. So creating an object is almost the same as saying you're instantiating a class. So you're getting an instance of a class. So this is an instance. And if I get the type, you can see now main references the document, whichever the module you're in. So you're in the main. And now we have it is part of this class, my pet. So I hope you're clear up to there.
Yes, you are.
All right. So in object-oriented, there are several concepts, and I will talk about. I'll just give a brief overview for understanding of four major concepts that we have in object-oriented programming. So we have inheritance, polymorphism, encapsulation, and abstraction. Those are very key, and they all involve creation of classes and creation of variables inside the classes, which we call now attributes, and functions inside the class, which we would call methods. So this is how we do it. So for example, we have a class, my pet. We would first, one of the main functions that we use is this init, which has two underscores on the right and on the left. This is called a constructor. So anytime when we did this, when we created this object, when we did the instantiation, this function init is normally called. This function is called, and now it can take up several arguments. So remember when we talked about function taking up arguments and parameters. Kindly excuse me for a minute. I need to do something. Just a minute. Sorry about that. I'm back. So as we were talking about the init constructor, this is what is used like to create the class, and it takes up several arguments, as we mentioned with functions. So this is like a special type of function. we call a constructor. And then the word self references the object itself that you're creating, like itself, it references the object. So you'll see us using self quite a lot of times. You can use any word here, but the convention is using self, so it's easier understood. You'll see many concepts using the self. Then you can take up arguments, can take up the name and the age. And then now here we would now say that this self, the name that we created, self as name, is now equal to the name that the user creates. So this is the object name, and the object age should be the age that the user gives us. So for instance, in this case, I create an object called dog and a object, and then I instantiate my class. Remember, in this above here, our class did not have any arguments or anything. It did not have any function or any argument that it needs to take up. But in this case, it has name and age. So remember how we did with functions. So we give our class a name and we give it age. So if I print the name and the age, I would get dog entry. So these are whatever we give. So our object has a name and age. So as well, let's see, we can also create another object. So let's say so what do? We instantiate the class. Let me just run this. Okay, so initially give us if as a pet. So maybe I don't know, call it oldie, and I think it's 1 year old. I hope we're together.
Yes, we are, Esther.
All right.
Keep on going.
So you have we are creating our object. So this is creation of an object. So this is how we're creating an object, and we can do the same thing. We can now get the we can get maybe the name. So the name, I can see the name of our fish is Goldie. This is now accessing. These are attributes of our fish. So our fish has a name and our fish has an age. So this is now how the basic creation of a class, objects, and object attributes. So in addition to that, we can also have functions in other functions inside our class. So in this same class, my pet, so my pet has, as you saw, it can take up name and age. We can also create an instance method. So a method that the object we can use with the object that we create. So maybe this object is this method, we named it describe. And anytime we have any method you create inside a class, you need to reference the self, which references the instance of the object. And as I said, you can use any other word, but self is the conventional naming method. So what does our function do? Our function would print that I am the name, I am are the name of the object and around the age like that. So it prints this is what our function should do. So how do we do that? So for instance, we create now we have created a class, we have instantiated it, we have given it the init, that is the init method to create attributes, and then we have created another method which is known as the thread that will print it out. So what do? We create two objects, dog object, cat object. The dog object, we give it a name, we give it an age. Same thing with the cat object. Now I think you can see like from a class, you can create as many objects as you want. You see now that I've created the fish object. So you can create as many objects as you want. So once we create this object, we can now run this describe. Remember how we now use something known as the dot notation. Remember when we said calling a function? We've called the function, but this function is an instance method. So it's an instance method of this object. So we say the object dot then calling the function. So the two of them. So if we run the two, we see that we have I am a dog and I am three. So remember you said dog and three, cat and 12. So our this is now a method inside the class. So this is how classes and methods and attributes can interact with each other. So what we can do, we can actually create another class out of this main class. So maybe, yes, we have a class known as my pet, but we want to create another class for dogs and another class for cats because no, dogs and cats are kind of different. So we need to create a blueprint that actually describes the dog and a blueprint that actually describes a cat. Both of these are pets. So we don't really need to repeat whatever like we don't need to repeat what is in my pet class. Like definitely a pet has a name and an age. So both cats and dogs will have a name and age. But maybe we have something different that we want to do for a dog and a cat. So in this case, we can now create a class known as dog class. Then it inherits from my pet. Now this my pet is known as the parent class. This class that we created up here. So what it does now, we now instantiate it. Remember the dot in it, we give it name and age. And this name and age, we would want it to get from the parent class, the attributes that have been described by the parent class. So it would take up attributes and methods. Now we can actually now use methods from the parent class inside this new class. We don't really need to redefine the methods that were in the parent class. And to do that, we use this functionality, super in brackets, the dot notation init, name and age. These six name age are actually parameters that were in the parent class. And then in addition to that, now our new class our dog needs to say something. So our dog can say, my name is Buck and I bark. So what happens is we can now create a new object of the dog class. Now this time it's not my pet, but of the dog class. And we give it the name dog and we say it's 7 years. So we can use the describe. You see in the dog class, we don't have a describe method. The describe method was in my pet. So we can use, we've not created, the D1 is an instance of dog class, but now it can use a method. Since dog class inherited from my pet, it can use the describe method that is in my pet. And as well, we can now add another function that's specific to the dog class. We can use that too. So if we run this, let me run this. So I'm a dog and I'm 7 years old. My name is Dog and I bark. So it inherits from the pipette, and it can also use its own function in the dog class. But something you can see, remember, this dog object was an instance of my pet. So can we really use the say something method? Let's try and see. If we use the say something method, what does it tell us? Tells us an attribute error. My pet object has no attribute. Say something. Because say something was not in my pet, but in the dog class. So that is the concept of inheritance. You can now create a class, and this are known is either a derived class or a subclass of the parent class, which now extends it extends the functionality of the main class. So we can also, there's also another concept. I hope inheritance is clear. We now go to polymorphism. So polymorphism is away in the wording itself. So for instance, if you see a very perfect example is this cat, mouse pointer is not a mouse pointer, but it can either be this arrow or it can either be this. This is polymorphism, like the same thing in different forms. So we can actually create the same attribute name, but having different functionalities. So, and the goal of this is to make it simple, make the work writing your code simple and readable and easy to maintain. Such that we can, for example, let me just I prefer like using examples instead of describing English. So, for example, we stop now. As we continue, we will keep on building on different concepts, one on top of each other. So now we can create a cat class. In this cat class, we inherit, as I mentioned, and then we also have a function inside it called say something. But in this case, they say something is I pass. This is what a cat does, and this is what a dog does. But you can see the function name is the same, say something. So polymorphism comes in whereby if we create this class, we can now create two objects, animal one and animal two. Animal one is an object, an instance of the dog class. So if you watch, I'm a fan of Mr. Robot, he had a pet called Quatty. So this is the name, not I being the intentional language Quatty. So, and then animal two is an instance of the cat class. So we have two objects referencing two different classes. So, and then now with both of them, we're running the same function, say something, say something. So we would expect that this would do the same thing. But if we run it, we see that this is I bar and I bar y, because this is now what we call as polymorphism. The same thing, but doing different things. Since now say something as defined in the dog class was that it barks, but as defined in the cat class, it does. So that's mainly the concept of polymorphism in object-oriented programming. And we have encapsulation. Encapsulation is whereby as a programmer, you'd always want whatever that is in the class, you call attributes or methods within that particular class. So what it means that like a class in itself, you said it's a data structure. And it should, everything that you do inside that, anything that you do in the class should be sent inside that class. So we would not want to reference something in a particular class outside that class. So most of the time, so a class in itself is an example of encapsulation, whereby everything, all the methods, the data types, everything are inside one particular class. And we would want to maintain that throughout our code, because that is now how object-oriented programming should work. And how Python enforces that is by using attributes, by changing how attributes are interpreted. And this most of the time is that we don't really want to access attributes from outside. Like if we have an attribute in this particular class, always and always that object of that class should only access attributes of that particular class. You should not be able to access attributes of a different class by an object of by an object that's not in that class. So as we have done so far, we can now have a different class. So this class, what it should do is that it should create a class known as counter, and then initialize it and we can now explicitly, like inside the class, declare the value of this attribute current, and we give it 0. Then we create another function that now would increment the 0, add 1, 1, add 1, would get 2, 2 add 1, get 3, something like that. Then the value would return the value itself, not the value that we've got after doing the increment or after doing the reset. Thereby the reset changes the value current back to 0. So in this case, what do I want to show with this? I want to show you what I mean by accessing attributes of a particular class, and how you can change attributes of a particular class. And as we go on, you would see what is the importance of being able to maintain your code in that kind of way, like this class, like now the concept now of encapsulation. So as we have been saying throughout so far, we instantiate an object. I created a counter object as an instance of the counter class. So I call the increment function 3 times. So if I call it 3 times, this means for 0, add 1 to become 1. And then the second time I call it to become 2. Third time I call it to become 3. So we expect to get a value of 3 because we've called the function 3 times. So maybe you feel that you want to access that attribute. You feel like I really don't want to run this method all this time. So let me just change this counter.current. So I change it to say, let me give it a value of 9. Let me do that. So now our object, remember object.value, what does object.value do? When you call the value method, it gives us the value of self.current. So we have actually changed the value of this outside the class. We have not changed here inside the class. We have changed it outside the class. Here like this. And that sometimes can be a bit dangerous. Not advisable to do that, because maybe this is a program that should actually count from 0. This program like really needs to start counting from 0. So if you come and change it and make it 9, that's a bit not right. So what happens is when you're writing your code and you want to indicate to someone that this you're not supposed to do this, we use private attributes. A private attribute would not do anything as such, but be like a conventional way of doing it in Python. So that is like an indicator for someone, hey, don't mess with this attribute. This is very important because if you change it, you'll you'll do you'll affect it in a particular way. So programmers would tend to write a single underscore before the attribute name as shown in this code. So this wouldn't if I would just decide to ignore it and just do create an object of that class and maybe now since the object was 9, maybe give it, let's say that I just wanted to start from that value, 9,000. If I run it now, you see the value has now changed to 9,000. So that private attribute is just an indicator, but nothing happens to it. So to actually enforce this, we use something known as name mangling. So we put double underscores and probably sometimes the underscore. But if we just use the double underscores before the attribute name, this enforces that aspect that we cannot change this. So let's say, because now I gave it, now let me run this again. Let me create a class. Our current should be 0. So I just come and say, let me just try and change it the way I'm used to doing it. Let me make it 9. So if I run this, you see, I'm not able to change it from 0 to 9. So that is now a way of showing encapsulation. However, we can actually change this, but now we have to reference the class. So anytime you do the the 2 underscores before the name, what Python does is that it interprets it into the underscore, the class, and then the attribute name. This is how Python changes it, reference that. And for us now to be able to change to reference that, we have to reference it now how Python has changed it. That's how what is known as name mangling. It changes the name into a different way. So it now references the specific class and then the attribute name. So now because we created an object, this object, we created it. Now we can now call the class discounter, and then now the attribute, and then change it to 9, and then let's see whether that works. As you can see now, we are able to change it. So we have to go through this entire process to change it. We cannot just do like normally, like just change it manually. We have to reference it that way. And what is the importance of that? Maybe, for instance, let's go back to our case. So we have our dog class and we have our cat class. So maybe we have we have dogs and we have cats. We keep that, and maybe this pet belong to a particular owner. Hypothetically, let's just picture that they belong to a particular owner, and we have implicitly said that the owner of the dog class is Esther, and the owner of the cat class is still Esther. Yes? So, and in addition to that, both classes, this is now goes back to the concept of polymorphism. So this owner is an attribute name, but we can also create a function known as owner. And now this owner, what does the owner do? It will print out to us who the owner is of that particular object we create. So any dog that we create, any object, any dog that we create, any object of the dog class, or any object of the cat class, the owner would be Esther and the owner would be Esther. And Esther is just monopolizing that. So that is just trying to make you picture this. And us to understand why we need polymorphism. Encapsulation. So what we do, we just do as usual. We create a dog class and a cat class. We create an object, animal one and animal two. We give the name and the age. So we want to print out who is the owner. Did I run this? I think I'm forgetting to run the class definition. So Esther owns the dog, Esther owns the cat. So maybe someone says, Esther doesn't need to monopolize this industry. Or because Esther comes from decides, let me just sell this pet of mine. So we want to change the owner of the dog and the owner of the cat to different people. So sometimes we might have been writing, this code might have continued for a long time, or even it's a different, because we can even use this, and as you see with the abstraction, we can use different modules, or this code is in a totally different place from where we defined our class. So if I was to just say animal.owner, I wouldn't be sure, am I changing the cat owner or am I changing the dog owner? So we are not really sure. But now, if we use the concept of encapsulation, whereby we have created these two underscores, that would mean for us to change. So the programmer initially knew we might want to change this and this to a. So let me enforce it such that for someone to change this dog class, they have to call the dog class. And for someone to change the owner of the cat class, they have to call the cat class. So they start by doing that to double underscores. And for us to change the owners from Esther, we have to now to call the dog class and the attribute, and now the owner becomes George, and then the owner of the cat class becomes Anne. And if I run this function again, you can see now that we have changed that George owns the dog and Anne owns the cat. So these concepts are just ways that would help you make your coding experience and your programs more efficiently, more simply, more easily. You can even maintain. Because now, if you were to start maintaining this code, you're not the one who wrote it. It would be very difficult for you if you do not know animal who is an object of cat class. But now, if you can you can actually reference the classes. Maintenance now becomes quite easy. And the last concept that we talk about is abstraction. So abstraction in itself as a word, as I described with polymorphism, abstraction is like hiding away the complexities of a particular task. For example, when you buy a laptop, you may not, sometimes we buy laptops and you need to install the OS, or we get even laptops that have been installed, the OS is installed. You don't really care how the RAM works, so long as you find the laptop on. You don't go and start opening the laptop and start rotating the CPU and start interfering with the RAM. You really don't care about it. These are complexities that are hidden away from you inside the system unit. Your main work is I need the laptop to work. I need to write some code. I don't really care if the RAM is from this manufacturing company. That does not. So that's not the concept of abstraction. There's someone who really cares about the RAM, but that is maybe a manufacturer or someone, a technician who. But if you just need to write code, you just need to type a Word document, your work is writing reports. You really don't care about what's inside the code. That's the concept of abstraction. So even in object-oriented programming, we sometimes we can import or get classes from people who wrote this, wrote different methods, different attributes. We really don't care about everything we wrote. We just want one particular thing. Because they might have written 1,000 lines of code, but we just need 3 lines. So that is how the concept of abstraction. So for instance, we can import this from ABC. ABC is a module that was written, and one of the methods that were created was an abstract method, a method that would create an abstract method. So we have from ABC class, import the class ABC and the method abstract method. So now here we're looking at, we really don't know what ABC is all about. We really don't know what it is all about. At the moment, as I speak, we don't know what ABC contains. But we want to import a class ABC and we want to import this method. So maybe you know what ABC contains. It contains like it enables us to create an abstract method. I have just told you that's what it contains. So we now create a class. Remember how do we create a class? We create with the class keyword, name the class, we use the class keyword, name the class, then we inherit from the ABC class. So we're inheriting all the methods and everything that are there, all the attributes. Then we can create our own function inside our new class. Again, now we use this is a decorator. Remember we inherited this function, we use this decorator, and this now creates an abstract method. And one thing about abstract, so in this case, this is what we call, in this case, all this we have created is an abstract class. One thing about an abstract class is that it cannot be instantiated. It's just there. Any class that, when we say an abstract class, is any class that has an abstract method. And how do we use abstract methods? We use abstract methods by creating different classes. So if you can see, even if I run this again right now, you can say can't instantiate abstract class. That is the error that Python tells us. So to use this abstract class, what we can do is create another class, inherit from the abstract class, and then override the abstract method. Now we make it a normal here inside this and inside this. So that's how we use an abstract class or abstract method in an abstract class. And for this to work, for an abstract class, we only need to override all the abstract methods in an abstract class. Once you inherit, if your parent class is an abstract class, you need to make sure that you override all abstract methods for that to work. In this case, we just had one, that's why we just did that. And now we can now create objects of now this class. So as you can see, we use now the class. But now we can now be able to use the print method. The print method is not in the classes, but it is in the abstract class. So now we can be able to use the abstract class. So if we run this, as you can see, now this prints out we are now in the test class, and now we're able to use both the abstract methods and the methods inside the abstract class. So that's just the concept of abstraction. Like you hide from the user what the user doesn't really need to see, and they use it whenever they need it. You don't have to show everything to the user, or you don't have to that is now how abstraction works. So basically, that is a brief overview of object-oriented programming. And you have a question about it, feel free to ask. I think I've covered rough overview of objects, classes, and objects. Yes, thank you. Any questions? So if there isn't any question, maybe Ruth, you can continue.
Esther, you done or you still?
I'm done with objects and classes.
Okay.
So yeah.
Okay. Keep on going. Let me know if you need me. I'm still here.
Yeah, so I was saying if maybe Ruth would continue with file processing, then I'll go back
Okay.
to regular.
Yes. Yeah. So Ruth will take from here on file processing. Ruth, go ahead when you're ready. Thanks.
Ruth, you're on mute if you're speaking.
Hi, can you hear me?
Yes.
Yes.
Okay. Can you see my screen?
Yeah, we can see it.
Yeah, so Esther has been taking you through objects. And one of the objects that probably you have not touched is files. And I know until now, most of you have been reading and also writing their input and output using the keyboard on the screen. And probably you want to a situation where your data is stored in some form of a file. So I'll be taking you through file handling and also something called Python Pickling. A file is just a form where a form of storing your data permanently, so that when you execute your code, it's not just disappearing on the screen, but it's something that you can be able to refer to later on, probably a database or a text file. So a file is very important. It helps us to store our data. So I'll just take you through briefly some of the commands that are involved in when you're using file or operations. One of them is you need to open a file. If the file is already existing, you need to open it. There is a mode called R. So that R means read only. So this is just a default mode. Then I'll demonstrate this and do it practically so that you can see what it is. Sometimes you can save a file in binary format. We'll do that when you're doing pickling. So that R you read, and B means the file is in binary format. When I say binary format, I mean that the text inside the file is in form of ones and zeros. Then we have R plus. It's the file is open for both reading and writing. Then we have RB plus. the file is open for reading and writing, but in binary format. So that when you see that B, it stands for binary format. And I've said binary is when the file is in format for zeros and ones. That is how computer works. Then we have W, when you want to write, the file is for writing only. Then WB, you want to write, but the file is in binary format. Then we have W plus, so all this maybe you can access them later. Then another important mode is A for appending. When you want to append something is to add data into an already existing document or existing file. So you want to add that more data on top of what you already have. So the file exists, but you want to add more. And then we also have that option A and B, that is append, but you're appending to a file that is in binary format. Yeah, so there are those several options. I'll just take you through the file operations. Let me share screen again for other files. Let's say you want to write a Python file. Writing means you actually put data into that file. So I was just taking you through the mods, the various mods that we have. So in my case here, I have a file called My Story. So we have options A and option W. So A is for appending. And I told you that appending is to add content at the end of that file. Then when you use W, it means you are overwriting. So if there is content inside that file, it means the content will be removed or deleted. So it will be replaced by what you are trying to put inside. So we have the format for the file. For example, if you say, Esther was talking about assigning a variable to the object. So our object here, which is My Story, the file, we assign it to a variable called F. So the computer will access that F, but the actual object, which is My Story, is our file, and it is a text file. And then when you say f.write, writing means we are putting content inside that file. So in our case here, the content is the text that is in double quotes. Now the file has more content. So that is what is in our file. Then once you have written inside your file, then you can actually now read the content. So we'll say F is equals to open my story.2.txt. R is for reading. So you open your file for reading. So after you've appended into that file, you open it for reading. Reading means you access the content. So reading means you access the content. If you happen to use W once more in that file, it means you have overwritten, which means you've wrapped what is already existing in that particular file. So in my case, I was using different examples because if you have My Story 2, My Story 3, then for demonstration purposes, you'll be able to see that the data has already been deleted. So how do you create? To create a new file in Python, use that open method. So let's say we have a file, a text file called My Fruit Files, and that is extension txt. Txt is just a text file. We have different types of files. If you are creating a Word document, you'll see it written .docs. If it is Excel, XLX, like that. So a txt file is just a text file. You can access it using Notepad, and you'll be able to see the content easily. which will be creating, I want us to access that. I'm going to demonstrate that using Python IDE. So I'm going to share with you some of the samples that I did so that we can check together. I hope you're able to see my screen. So on my screen, I have a variable called f, which I was showing you through Microsoft Word. And I want to open a file called my story, and my story was created using a TXT option, that is Notepad. So if you want to open this file, you give it you assign it a variable f, open my story.txt. So I said we have the f.write. Write means you want to put content for it's like you're putting it for the first time though, or if there is content already, then it will replace what is already inside. So when I say f.write, it means I want to put these words. Now the file has more content into that particular file. So you can use this to create a new file. So make sure that you close the file, and then you can open and read the file. So when you're opening and reading the file, you'll put the R option, and look at the way the R has been, it's under quotation mark, the double quotation mark. Then when you want to read the file, you say, you put your variable f.read. Then look at the closing brackets. The print statement, we have opening brackets, then .read. Then read, again, we have closing bracket, closing the read method. So in that file, I had that statement. Python is an interpreted. So whatever you're seeing here, Python is an interpreted object-oriented, is just text that was typed in that particular file. So when I run this command, it's able to display, when I run this command, it's able to display that text on the screen. Probably this will change when I run. You just press Control Enter to run that statement. Then for the second one, again, Control Enter. So it's still having that statement. When I go to the next statement, my story 2, I'm using W option, and W option will overwrite what is in my story.txt. I'll access them in the folder so that you can be able to see. So let me just share with you what I have in my story 2. Then you'll compare with what is here. So these are a list of my files. There are so many. Yeah, so need to be patient. So you can arrange your file according to group by name so that you're able to see the names of your files. So mine, I was calling it my story. Yeah, so my story 2 is here. So you can just open so that we view the content. So open. So this is what is in my story 2. I can add something here. So I'm saving it. Then you've realized that I've added some text. Then let me save. Then let me run that my story 2 once more to see what has happened. So when I run, Control Enter. Okay. Yeah. Oh, that was, let me check where it was. Oh, sorry, I saved it in the wrong folder. Okay. Yeah, I've realized that I've saved it in the wrong folder. Anyway, it's supposed to overwrite the content. Then another option which you can have, you can also just extract the first 5 characters in your file. We can change this. So you execute, you can see now we listed the first 10 characters. I hope you're able to see my screen. So you want to read just the first 10 characters on your screen. So the characters are inclusive of the spaces. We also have another option which you can use to remove. You can remove a file using, you import OS and then os.remove, then you'll be able to remove. Because those actions need some time, so maybe you can access these documents later. Another option on file processing, I think open, read, write, close. That is basically some of the actions that you need in order to put your, I was using text files because that is mostly most of us are familiar with text file. So you can simply go to the text editors and then just type and give it that extension, then you'll be able to use it properly. So let me share with you how you can know the folder which you are supposed to be using. When you're running Python on the screen, you may be confused and you may not know the folder that you're using at the moment. So in line 5, you can say import os.get cwd. So it will be able to show you the folder where you are at the moment. Like in my case, I'm in C, drive C, users, user. So I'll be able to know exactly where I'm working from. So when you go to users, you can be able to create that file. And then once you've created that file, you can be able to open, write, and even delete or remove the file that you want to remove. So because of time, I'll just go straight to the other part, which I was supposed to show you. there is something called Python Pickle. So Python Pickle is a module which users can use in order to serialize and to deserialize a Python object. Esther was talking so much about Python objects, and remember the data types that you had learned before, like lists, and also the sets and dictionaries. So just like I'd mentioned earlier, you are just using the screen and the keyboard to display, input and display your data. Suppose you wanted to put these files or the dictionaries and the lists also on a file. I've just demonstrated using a text file. So Python Pickle can help us to put our lists and dictionaries also in a file. Why is this Python Pickle important? It is important because sometimes we want to transport this data over a network. And when you're transporting data over a network, probably you'll not be able to transport them as TXT files. So you need to transport them as binary files. So remember, binary files are files that are in zeros and ones. So Python Pickle will help us to transport our files over a network. Then we'll be able to maintain the program state across the session. So the program will not be changing, like interfering with the codes. So we'll be able to maintain the session, whatever we are doing. Then when we are transporting these objects, they are converted to what is called a byte stream. So the byte streams are the zeros and ones. So there are other ways which other libraries like modules like JSON, maybe you covered that, which you can use instead of Pickle, but in this case, I just want to demonstrate Python Pickle. So just like I've said, you want to transport your data through a data network, or just to maintain that data integrity because you don't want it to change. So in the other example, I was just showing you how to use a text file, but in this case, you have your lists. So if you can see on my screen, we have a list of a list of cars. So we have Toyota there, BMW, Audi. So what you do is, first of all, you have to import Pickle. So what I have in the second line there is just a comment. And the third line again is just a comment. Then that is the name of the list, the car list. Then you have to say with open, and remember the file operation commands. We have open, yeah. So we have the car list.txt, I've used that. Then remember W. We were using W for write, and then the B for binary. So you assign it a name as car pickle. So that car list.txt, you write it as a binary file as car pickle. Then look at the end of that line, we have a full column. Then pickle.dump. Then this will place the content from the list. It will put it in the variable. This is a variable. The car pickle is a variable. So it will put it there. So when you run this, Control Enter, the file car list.txt will be created, and it will be created in the current session, the current folder that you're working in. So at the moment, I'm working in drive C, users, user. So if I go to this drive and folder, I should be able to identify this file called car list. You'll be able to get that file. It will create it. Then if you want to unpickle, so which means this file is stored, I'm going to show you just in a little while. If you want to unpickle means you want to get it back to the way it was, we call that unpickle. So you'll open the file, which is already created in your folder, the callis.txt. Then R stands for reading, which you are reading the binary file, and you give it a variable name, a pickle. So I've given my variable that this car pickle.load. So we are now loading that into the memory. So we are loading that and using the car pickle variable. Then print statement will display now the content on the screen, just the way you've been using it. So we say print this car. So this car is just a variable. Then we assign it to the variable which stands for the file. You don't use the file direct. We don't say car list.txt direct here. We have to assign it the variable. So that's why we are saying as pickle. So this pickle, a pickle is what we'll put here. We don't put car list directly here. So we say print this car. So we use the variable which is on our left-hand side, and this will help us to see the content. So the same pickling, we can perform that on, this is a dictionary, sorry. The same pickling, we can do, perform that in a dictionary. So this is supposed to be cars. So this is a cars dictionary, but not dictionary on cars, but not on, we are using dictionary. So you can use dictionary, you can use, we can use the list. So let me just show you this file, the car pickle. Let's say we want to check the content. So car list.txt. So I'll share that from my folder. So you need to group them again, sort them. I have so many files, I'm sorry. It's a car list. Okay, let me search here. Car list. Okay, so here it is. So if I open this file, I don't know if you can be able to see my screen. Maybe you can respond through the Zoom message. Yeah, the file is in binary format. Yeah, so that's why you are not, you are able just to pick Toyota, BMW, Audi, but the rest of the characters are in binary format. Yeah. So it's a very interesting thing. The word sounds big, but it's a very interesting module in Python. If you have any questions or something that you want to ask, please do, because I think I'm done. It was just short and it's very direct. File operations are the easiest, and also pickling, I think it's a very direct command to practice. Thank you so much.
Thank you, Rose. Do you have any questions? Thank you. Any questions so far? Any comments? Anything you would want repeated? Anything that wasn't clear? Okay. All right. So we will now continue. So here I have a very weird looking list of stuff. We'll actually see how to use that soon. Yeah. Oh, okay. So let's talk about regular expressions. So regular expressions is not a concept that is really tied to Python, but similar to object-oriented programming, it's something that we use quite often, knowingly or unknowingly. For instance, when you go to your contact list and you wanted to start to call Zipporah, you start Z, I gives you that, then Z, I, like you search. That's an example of how we use regular expressions. When you go to WhatsApp, someone sent you a text. You want to find it, but maybe they sent you a number or something. You want to find it, but you can't. It's like sent you like 3 months ago. You have to start searching for that text on WhatsApp. That's regular expressions. So they use the concept of, we're using the concept of regular expressions. So what are regular expressions? They're just sequences of characters that create a pattern. And most of the time, we use regular expressions to look for stuff, like looking for a needle in a haystack. So you might have big documents. Maybe you want to search for something on a website. How we use Google is more or less like regular expressions. We search for whatever we want. Google looks at it as a pattern of letters and like, okay, this makes sense. Let me search for websites or content that has similar content to whatever this search pattern the user has entered. That is regular expressions. That is on a very high level what I'm talking about regular expressions. However, we use regular expressions in programming whereby we might want to look for specific kind of patterns in our data. In data science, you might be given a lot of data, but you need to get a specific thing. Maybe you have sales kits, but you want the data for a specific brand. The data is not really organized, so you need look for a pattern. This brand uses this kind of letters, they use this pattern. Or you are searching for data on an online website. Sometimes you even wonder, how you get weird text. How did this person get my number? Maybe they used regular expressions and did web scraping and found your data on a particular website. So those are very many use cases of regular expressions. So in Python, we can use regular expressions. We can use regular expressions on actually the command prompt to search for files. The way Ruth was doing, searching for a file depending on the file name such this character. On the command line, you can use that. On using other types of scripting languages like Bash, which I know of. Other programming languages use regular expressions as well. So with Python, we use the re module. Remember, I talked about in object-oriented programming the concept of abstraction. Someone wrote a module that would basically do regular expressions on Python. And that module is known as RE or V, whichever sounds good for you. So in the V module here, this is how we do it. You import a module. A module is like a group of programs that have maybe different classes, mini classes, and methods inside it, which come and create a module. So one example is this module. So in this module, there are particular methods of interest for us, or functions that are of interest that I shall cover. I will not cover everything in regular expressions. I will just as usual, let's do a brief overview, which should make us understand and know how to use regular expressions. So we have some particular functions of interest that we will use quite often. And these are the read.compile. So the dot compile function or method. So what it does, it compiles a particular pattern into a regular expression object. And now whatever pattern you have created, you can actually reuse it. Then we have the search. The search returns a match object. So if you search for a particular pattern and it finds it, it will return an object that contains data about whatever you searched. If you don't find anything, it will return none. Then we have find item. So for instance, search finds the first occurrence of that particular pattern. Only that, the first occurrence. However, with find item, it will find all occurrences and put them in a list. So it's a list of the match objects. Opposite from find item, find all would find the occurrences of that particular search pattern, return it to you in a list. So the ITA and the search return match objectives, we will actually see how they work. Find all actually returns the particular pattern that you have requested to search. Then we have the sub function that is like substituting. So you give a particular pattern, and then you say, this pattern, I want you to substitute. Maybe you want, let's say, girl, GIRL substitute with boy. So anywhere in your document or whatever you search in, especially let's use this context of a document. Anywhere in the document where you have girl, just like find and replace. You have girl, it will get between substitute with boy. Then split. So in split, the split separates a particular string dependent on what separator you have declared. So if you said separate it dependent on the white spaces, which are like blank spaces, it will separate, like if you say, I am a girl, so it will separate the words. Like it will give you like I as a particular word, am as a word, a word, that. So it will separate them dependent on spaces. You can say maybe where there's a comma separate, where there's a semicolon separate, stuff like that. So these are the functions that I found to be useful. However, when you go to the Python documentation, and this is the link, you can find this notebook and all other code, any other code that I've shared during this class on my GitHub. I will share the link, all that material. You can now click on this link and you will go and see and read further, get more insight. So below is a simple doc string that we would practice these functions and other concepts and regular expressions on. So we said earlier, import C, and then this is a text. So bear in mind, all these are not different strings. All this is one string. Have that in mind. Like I just separated them for visibility, but Python would interpret this as like say just one sentence. Okay? It's not they're not separated as sentences or anything like that. So Python interprets it as last string. So read.search. We said that read.search looks gets the first occurrence of a particular pattern. So how do we do that? So we have a variable, call it a match object, because we said it returns match object. You can call this variable anything you want. So we say v.search. We want to search for a pattern A, B, C, capital A, capital B, capital C. Inside the text to search. Text to search is this. I put all this in the variable text to search. So you're searching for this pattern and you want to find the first occurrence of this. So if I run this, I would get so if I was to search for this, I would get, remember I said it returns an object and it's case sensitive. It is per 92 to 95. So this is like the location, right? So the first ABC, and it is case sensitive. So working with match object. So if the match object, we find the particular one is the span. It contains where it starts, the position, and where it ends. It starts at position 92 here. And this capital ABC is very different from, say, if I say ABC, small letters. If I run that, you see now it gets 35, 38. So this is it's case sensitive. Always be mindful of that. And we will see ways to work around that. Sometimes you might want to search for both capital and small letters. So we will see how to go about that as we continue. In addition to the span, our match object also returns the string. So the particular string that you were looking for, or it can also return the group. So the part of the string where there was a match. So I tried them out. So here in this, I printed out the span, I printed out the object, the group, so where it was found, and I also printed out the string. So if I run this, we find that we can get the match of the span is where ABC, the first occurrence of ABC is at position 35 and end at position 38. And then the start, this are the start and indices, so like 35 and 38. Then the group is ABC, so this is just showing you whatever pattern you're looking for. And then the string would return this entire string that you're searching for. So that's for the search. So when it comes to compile, what happens is now you write your pattern and then you save it in a variable. So now when I save it in this pattern, I don't have to keep writing, the pattern that I want. I can always reuse this pattern. So how do I reuse it? For example, I want to find an iteration. So I would just say pattern. So pattern references this So I want to find every object that has this pattern in the text to search. So how do I, so if I run this, I get all this matches, these are all the objects, and it even gives us the positions where ABC is found. We can as well, still with the recompile, we can as well now find all. Now I want us to look at the difference between find item and find all and see how we are using our search pattern with the that we compiled earlier. So it gives us it just gives us a list of, and we can do quite a lot with this list now. Instead of giving us all these details, it just gives us a list of them. Then we have read the tab or read the tab. So I want today I've talked a lot about cats and dogs. So we will substitute in our statement here. I think we have the word cat here. So we want to change this cat to from I love cats to I love dogs. So what do? I read a tab. So I want to substitute cat. Sorry, I want to substitute cat with dogs inside the text to search. So if I run that, so now you can see that now I love dogs now. We have substituted. Then we have split. So split we said it splits where we have, so we have seen now this is something different. This actually means something when you're using regular expressions in Python, or actually regular expressions. And this refers to white space, any white space. When you use backslash s, this refers to white space. So we want to split our string to anywhere where we have white space. So let me just click that. So as you can see now, it has split our string. So you see, like ABCD, this doesn't have any white space in between. So it makes it like one word. And stuff it makes it into individual strings. So we had one string, but now we have several strings. So that's what it does. So as I said, this is a special character. And we call them meta characters or special characters. So these are characters that are interpreted in a special way. So the re module that we import will interpret this differently, and Python will as well interpret them differently. So when we use a backslash, it escapes the special character or denotes character classes. Either it will, because we have some special characters that we use commonly, like the period or full stop, which we shall see here. So if maybe we don't want our search pattern, maybe we want to look for Mr. Sam, and the Mr. at the end has a full stop. If you really want it to be interpreted as a full stop but not as a dot, which is a special character, we put a backslash before the dot. So for instance, this is we're looking for all occurrences of a period of a full stop in our. So we need to use this backslash. When you suspect like that this is a special character, use a backslash before it to be able to find exactly what you want, not something different. Because if you are not to use the backslash, for example, this, so in the difference between this and this is that we have not used the backslash. So if I run this, it would give me this. And what does that mean? It matches anything and everything except a terminator, like a new line backslash and something like that, a line terminator. So that's there. So I think you can now see the importance of using a backslash. Another character is this upright, what we call it. And this matches the literal, that a literal in this case means like literal, like a string or statement or something, at the start of a string. So it checks if the string starts with that particular letter. So in this case, we want to check, does our string start with this pattern, PHIS with capital P? Let's check. And it returns an object and it starts from 0 to 4. Let's say, because I remember I mentioned it's very case sensitive, I put a small string. It returns nothing. So it means that our string does not start with this, it starts with capital P and capital P. Okay. Then the dollar sign checks whether a string ends with. So I did this intentionally and I was writing my string. So my string I know ends with end, the word ends. So we can, so yeah, it does. So we can actually print out our string. It starts with this and ends with end. So these are how we can use the special characters. These are examples of special characters. Another example, and here I would like us to pay attention because the following three are quite confusing and you would use them a lot. So just pay attention. So question mark. So you put the question mark after some particular word, letter, sorry, or a particular character, not a character that you would want to search. And this should return either 0 or 1 occurrence to that, to the left of it, the character to the left of the question mark. So for example, I have a phrase here, has the word pan, double N in Japan, and pan in several A's, or PN lacking an A and PN. So we want to look for a pattern whereby we have PA question. So we want to find where we have the pattern with an A and with an M, but in the middle it can have either a 0 or 1 occurrence of the letter A, but it should start with P and with N. So what would be the outcome of this? So this is the outcome. So as you can see, it has only printed out this no, because these are two. Pan, this is the second pan. If you count 14, if you count the number of characters, it would be like 14. Then not this because it's a more than one. PN, yes, because it's a 0, it did not occur, but it started P and it N. PUN, no, because why? Yes, there's no A, but as you can see, our pattern is not PN, but PUN. So that's why it's not in the stand. That is how a question mark. So question mark must be either 0 or 1 occurrence. Asterisk must be either 0 or more. So it can be 0, 1, 2, 3, 4, 5, 7, seven number of occurrences, just the same as how we do with the question mark. So the same thing, the same statement, instead of a question mark, put an asterisk and you see that it matches more values, the ones that the AA that were not counted with the question mark. Then we have plus. Plus matches 1 or more occurrence. So it has to have occurred. It has to have 1 or more. So if there's no occurrence, it would not be matched. So in this case, as you can see, PN is not returned because there's no occurrence of the letter A. I hope that is clear. Another character are the calibrations. Inside calibrations, we can put a specific number, and this would match the exact number of occurrences. So in this case, we are looking for the ABC. So ABC, and it would search for exactly 5 occurrences of ABC in text. So if I run that, it only has 5 continuous occurrences. Then we want to look for 3 occurrences. It will only match exactly 3. So we have 2 occurrences of exactly 3. So that's how that works. Or sometimes you might say, okay, I don't know an exact number. I don't really want to give an exact number. So I can say match 1 or more occurrences of this. So as you can see, I'm using brackets. Now brackets groups ABC into a particular pattern of its own. Like ABC is now a pattern. It's like it takes it up as one let of word ABC like that. So we want to match exactly 1 or more occurrence of ABC. And you see you have so many occurrences of ABC. Then this matches at least 2 or at most 4 occurrences. So we have so we don't have 2, we have 3, we have 4. So that is if we how to specify the number of occurrences that we want. So and then we have this is an OR. I think you've seen the OR operator at some time, and it just basically does the same thing. So you remember we can now say match either ABCD, capital ABCD or small ABCD. And it would actually now return these occurrences of ABCD. So remember we said this case sensitive, so you can use the OR operator to say the small letters or capital letters. So the brackets groups it as we saw, as we've been seeing throughout with the ABC and ABCD. It groups them into like a sub pattern. That's like I want this specific for ABCD is supposed to follow each other like that. Then square bracket matches any single character in a bracket. So difference between parentheses and square brackets is that the bracket treats everything in the bracket as an entity. But when something is inside square bracket, which we shall look at practically, it only looks for one of them. Even if you have like 100 characters in the square bracket, if one is present, that's okay. Like doesn't have to have all 100, but so long as one out of the 100 is present, then it matches. However, inside the parentheses, all of them have to be there. So that's the difference between the parentheses and square bracket. Then when you add an up caret inside the square bracket, this denotes like the opposite. So not so anything that matches anything that does not have whatever is inside the bracket. Then we can also search for special sentences. So and this is where now we look at now this. We always like there's particular things we always want to search for in a document, and we have some characters or ways we can use search for these sequences. And it's advisable to use a row string. And what is a row string? When you put an R before the string, it makes it a row string. So what does that mean? It means that Python interprets everything that you type literally, like \n\. When you type \n in Python, it stands for new line. If you type backslash, it stands for tab, but if you put a row string, it would interpret it as just you just type backslash. It won't interpret anything. So an example, so if you just have two different outputs and see it created a new line and then tab, but if you put a row string, just type in whatever you literally what you type in. So for this to work most of the time, sometimes it might work without a row string, but to be sure it works, for me, I like to be sure, so I use row string. So, for example, I want to find all the alphanumeric characters. Alphanumeric characters stands for alphabet and numeric characters, including underscore. We can use this backslash W. And backslash W, this is just a sequence. So it would be interpreted and we would find all of this or anything in our string that is alphanumeric. If you want to find the digits, like numbers, we use D and it finds all the numbers present in our string or whatever we are searching for. Remember, every time I mentioned the S, it searches for all the white spaces. So white spaces include a space or can include a new line or can include maybe we had a star, but doubt whether we had tabular. So those are the white spaces. Then if you do at B, it matches, it checks whether there's an entry space before that letter and after. So it's like basically checking, is this a word in itself or it's not? So for example, I can run this. So our string here, we have letters la and lala. So the ones that are like words that don't have like a space between them and start with the LA are two. Okay, you have three LAs, but the ones that are individual words are two. And as you can see, we have two. Let's say we want to check ABC, like individual words that start with ABC. So in this case, we have one, this one, 1, 2, 3, 4. So let's try and see. I really want us to understand what I mean by not looking for empty space between. So it finds the four of them. And when you do the opposite, it does the opposite. So it finds anything, like for example, if we do capital W here, it will find anything that is not alphanumeric. So if you know that there's the small letter, what the small letter does, to get the opposite, it gives us all these other characters. Get the opposite, we just get the capital of it. Say you want to find anything that is not a number. I don't want numbers. I don't want to find any numbers. So if you check in this list, we don't have any numbers. So same thing with the S, anything that's not white space is fine. So if you want actual letters, so as you know me, let's do practical example. So we have, remember I showed you this. So imagine you're working somewhere and you're given like a document that like, or you're even looking for a website or something, you're just searching somewhere and you have a document that is like 100 times this size. Okay? Like 100 times this. This is a very small document. So your boss tells you, okay, from this document, the next 2 minutes, I need all numbers from Kenya. So okay, let's 5 minutes. I need all the numbers from Kenya. So what do you do? First of all, think, how do we write for numbers in Kenya? So the country code is 254. So someone can write 2547, blah, 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 like that. Someone else can start with class 25476 numbers, and those numbers have to be like 10-digit numbers, 9-digit numbers. Or sometimes someone can start with 072536. So those are patterns. So we need to find numbers that have those particular patterns. So that is basically our task. We want to find the number from 10. So in this case, what did I do? Remember, Ruth has taught us how to access files. So we have a content.txt file. So this, my file is in the same folder, as this kind book. That's why I haven't written the folder name and everything because it's in the same folder. So I access it as F. So F would be the name of the object. So the file will be object F. So while the file is open, so I've opened my file, I want to read. So I want to give a variable. So numbers would be read.find all, find everything, a list of all those numbers which have this pattern. So I remember I said use broad string. So in square brackets, it can have a plus. So instead, some people use plus 254 and don't. So we need to put a question mark after it. Why? Because we want to find 0 or 1, not plus plus plus. No, just plus 1 plus or 0. That's why we do question mark. Then it needs to be 254. Then digits. So remember we said we use the special sequences backslash d needs digits, and we remember in calibrations we put the exact number of digits we need to find. So we know it needs to be exactly 9 digits and it needs to be this class 254 that. Now that is one way. Or someone else would start with 07. They need to start with 07 and then exactly 8 digits. So for me, this is the pattern that's in my head. You might have a different pattern. You might say, okay, me, I've noticed people write this way differently. Or I can even say someone can add 2540 something. So this is just mine. This is not the written down. This is how exactly you're supposed to. No, this is just sat down, thought about it, and came up with this. And we need to read the file that we have opened. So we're searching all this inside the file. And if I run this, I only have out of all those, these are all the numbers, but I only have 3 numbers which are valid numbers, which are valid Kenyan phone numbers out of all this data that we have here. Out of all this. So instead of that, we can use regions. Someone else would be like, no, I don't want Kenyan numbers, I want American numbers. Okay. Let's think same way we solve that problem. What are the patterns that are there in numbers with phone numbers in the US? So from what I have seen that they can either start with a plus, and if it starts with a plus, start with a +1. So I know it should have a plus or not, should have a 1 or not. You can have a hyphen at the end or no. And then from the list I have seen, some of them had put the numbers with brackets. It should be there or not. Then we have 3 digits. This one I am sure, like they are always 3 digits. So this is not a negotiable thing. Exactly 3 digits. And then also inside it can have, so dependent on what person started here, it can have either closing bracket, a dot, or a hyphen. Then exactly 3 digits, then a dot or a hyphen, then exactly 4 digits. So that's the pattern that I have seen. And if I do that, I can get this as my result. So someone will be like, hi, this one is that you've written that have dots. These ones don't look like phone numbers. So what do? I'm like, okay. And in my reset, in my pattern, what I need to change is just remove. I don't have, it should not have a dot after the three numbers. See, after this, like this one here, a dot, a dot. So, and also I remove this one. Then done that. Okay, now give it the point. So yeah. So that's why I'm saying it depends on you what pattern. So long as you know how to work with the functions, how to work with the special characters, all you need to get is the pattern. Another example is, this is a simple one. Maybe you have said, okay, I want a list of all the professors. So we know professors have their name with a prefix, prof, professor. So some of them might start with a capital P or R. Remember, whatever is inside the square bracket is not the two of them, it's the one. One is just one. So it can either be a capital P or a single P. Then the pattern is ROF after the P. Then some people put a full stop, some don't, but they use a question mark, 1, 0, or an occurrence of that. Then some people put white space or not. Sometimes some people forget to put a space after the prefix. Some people just forget, you just accommodate them. Then you can now say, when you say A to Z, so this means any small letter between A and A to Z, from A to Z, like the alphabet, A to Z. Then A to Z capital. So this is another way of incorporating both small uppercase and lowercase letters of the alphabet. So we can choose any of the letters. And now we put a plus. Why plus? Because there definitely has to be a character. Like, you cannot just have prof and then without a name. That is not a legit name. So professor so and so. So there has to be one or more occurrences of an alphabet. So that is how we search for names of professors. So now we see we can find this one wrote their name, let's see it down. So you can find at least we've accommodated so many, and this is how now we practical examples of how we might use regular expressions. The last one is getting email addresses. So how will I write an email address? You write something like wamboi@gmail.com or george@ithought something.edu. Those are different, or something dot Africa dot. So we need the different ways, but there are specific things that need to be there. We need to have alphabet, either a letter or a number or an underscore or a hyphen. That one needs to be there. At least one of them, even if it's A at or 9 at or something at. So it needs to be one or more. So that's why I will put a plus sign here. Then we need an at. So we have, I suspected that at can be interpreted differently. So that's why I put a backslash before at. So that it's literally, I mean the at symbol. At, then a particular character, anything at something, any character, dot. I put a backslash before the dot. Then any character. And these characters need to be between 2 and 6, not really long domain names. I looked at the main domain names and they're around this number of characters. You might think differently. As I mentioned, the pattern, this is my defined pattern. You can define your pattern differently. This is the pattern that I used to define email addresses, and in that I got email addresses. And you can see now from this document that now it actually makes sense. I can actually look for things, and on a larger scale, this is how we use regular expressions to get other things like logs. you might want to find particular timestamps, what happened during this time, or with this user, what did this user do with logs. You want to find a particular IP address in logs. So yeah, basically that's it for regular expressions. If you have any questions, comments, open to that. Thank you. George, I am done.
Are you done? All right. Thank you very much, Esther. And, do we have any question? Anybody? Paul or James? We're only two of us. And of course, we have Ruth and Esther. Do you guys have any question? This call has been recorded, so I'll go ahead and share in the group chat. And if you follow through and you still maybe feel like you need an area to be elaborated, please feel free. And this is our last Zoom session, so but we'll still have the class open online. So if you have anything you want to be answered, feel free to reach out. For Ruth and for Esther, thank you all very much for the assistance. And if we don't have any other question, I'm going to go ahead and stop the recording. And you all have a good day. Thank you. Thank you, Esther. Thank you, Ruth.
Thank you too.
So you joining our advanced class?
Okay.
Okay. Ruth, you can join. I know you're busy, but you can join if you want, Ruth. All right. Thank you, guys. You have a good one. Bye.
Okay.